Hi everybody, welcome to today's new math video. We are talking about bivariate data. We're in Unit 2, and the last video you watched was on two-way tables. Today we're going to continue the idea of two-way tables and specifically get into what are called relative frequencies. Relative frequencies. So, when you have a two-way table, like this two-way table that we saw in the last video, which was bivariate data, right? Why is this bivariate data? Because there's two variables, the pickleball variable and the kickball variable. And this bivariate data isn't being displayed on a scatter plot, it's being displayed on a two-way table. But what if I asked you, of the students who like pickleball, how many like kickball? Of the students who like pickleball, how many like kickball? So what we would have to do to answer this question is we would have to look at the column where it shows all the people who like pickleball. And there were 10 total people who like pickleball. Of the 10, 6 of those people liked kickball. So 6 of the 10 people who like pickleball liked kickball. So to answer the question at the top of the screen, 60% of the students who liked pickleball also liked kickball. Does that make sense? All right. So I also gave you the relative frequency at the bottom for the people who like pickleball but didn't like kickball. That would be 40%. These ratios can be turned into percents, and the percents are what we call relative frequencies. And we found these relative frequencies by going into the likes pickleball column. We could also find the relative frequencies of the other column. Of the people who don't like pickleball, how many do like kickball? How many don't like kickball? So I would look at this column and I would try to find some percents. And I would have to ask myself, of the people who don't like pickleball, which there were 5 total people like that, how many of those 5 like kickball? 3 out of 5. And what would the percent be? You know how to turn a ratio like 3/5 into a percent. That would be 60%. How many people who don't like pickleball also don't like kickball? That would be 2 of the 5 people, and that would be 2 out of 5, which is 40%. Okay, so we are now seeing what it means to find relative frequencies. It just means to find percents based on the two-way table. And you can also find relative frequencies by rows. So we asked the question earlier, out of the people who like pickleball or out of the people who don't like pickleball, but what if I wanted to know how many of the kickball lovers also like pickleball? I would need to go to the kickball like row that goes horizontally across the screen. There are 9 total people who liked kickball. 6 of those 9 people also like pickleball. So 67% of the people who like kickball also like pickleball. 3 out of the 9 people who like kickball don't like pickleball. There's your relative frequency for that. And if we did relative frequency with the other row, can you see what my ratios would be? So there are 6 total people who don't like kickball. 4 out of 6 don't. 4 out of 6 do like pickleball. That's 67%. 2 out of 6 don't like pickleball. That's 33%. All right, this is relative frequencies. It's just finding percents on a two-way table. One quick note, when we did relative frequencies by rows here, we got 67 both times and 33 both times. That just ended up kind of happening on this two-way table. That's not usually going to happen. It's definitely not always going to happen. So that's just kind of a weird thing that happened with this particular data. Don't expect that to happen every time. All right, your turn. In your video notes, in your packet, take this two-way table, which you should recognize from the last video. The 2 variables are, do you like math or do you like science? Or ELA versus history. And find the relative frequencies by column, then find the relative frequencies by row. So by the time you're done with this, you should have 4 different relative frequency percentages. So take a second, pause the video, find those 4%, the 2 sets by column and the 2 sets by row. So I guess that would be 8%. All right. Now that you're done with that, here's some more data in a two-way table. 100 elementary school students were surveyed. Do you prefer Bluey or do you prefer Bingo? Do you prefer Mario? Do you prefer Luigi? Here's your relative frequencies. You probably want to take a second and see if you understand where those numbers came from. So where did the 57% come from? 20 out of 35, and you can check to see if 20 divided by 35 makes 57%, 60 divided by 65, 92%, etc., etc. The question, though, that I want you to think about with this data, now that we have those 8 relative frequencies, do these variables show correlation? One of the big ideas that we've been talking about with bivariate data is, are the variables related? So is your feelings about Bluey versus Bingo related to your feelings about Mario versus Luigi? Maybe take a minute, look at those percents, and see if there's any conclusions you could draw. Is there a relationship here or not? And when we see each other next in class, we're going to try to answer the question, what does correlation look like in a two-way table? We know what correlation looks like on a scatter plot. What would correlation look like on a two-way table? All right, that is two-way tables and relative frequencies. Thanks for watching. Thanks for listening. See you next time.